Hello everyone, I'm Monish Nagaraj. Today I'm going to be giving a small presentation on MLOps and DevOps. Why data makes them both different? How does it differ based on the data which they are working upon? So this is a presentation on CSCI 201 course, and I'll be doing this under the guidance of Dr. Hubert Sikotti. So what exactly ops mean in MLOps and DevOps? Ops refers to the operations, collection of processes and the services that are performed on a program by the production and the operation teams. So with little to no direct involvement with the development teams, the operation teams are in charge of installing and administering the software. So we'll define one by one now. What exactly is MLOps? MLOps is a set of procedures aimed at reliably and efficiently deploying and maintaining machine learning models in production. And also the term is combination of machine learning and DevOps, as you can see, a software development approach that emphasizes continuous development. Let's move on to DevOps. What exactly is DevOps now? DevOps is a set of cultural concepts, practices, and technologies that improves an organization's capacity to produce high-velocity applications and services. DevOps also aims to bridge the gap between developers who write the application software and operations who run it in the production. So we'll talk about the infrastructure of DevOps and MLOps now. But before that, do data-intensive applications have that mainstream infrastructure to create and deliver them? Let's see in our upcoming slides. So the DevOps infrastructure, you can see it on the left, and the MLOps, which is in turn DevOps, you can see it in the right. We'll now get to know about the applications of MLOps and DevOps. So firstly, DevOps applications includes improvement in the product quality, having minimal costs of production and faster problem solving, while machine learning ops includes creating data pipelines, model preparations, and etc. So there are certain rules that have to be followed while running a process or a program, but who creates them now? In the traditional applications, the programmer who developed the app used to write the rules, but in MLOps, the machine itself creates the rules for the data, which are further used on the data again. So the DevOps engineer's roles are to write specifications and documentations, infrastructure management, performance assessment upon that, and cloud deployment as well, and etc. While the MLOps engineer role would be to design a model first and then develop the model and then perform operations again on the same model which he has created. So we're going to be diving deep into ML infrastructure, that is a modern stack. Firstly, we're going to be studying about the foundational infrastructure that consists of data and compute, and then we move on to the software architecture, which contains integration of both data and compute, which you have got from the previous layer, and finally the data science layer, which consists of iteration. So we'll talk about the first layer in the hierarchy, that is the data. So in this layer, firstly, it starts from data ingestion. We collect the data and then storing the data and then transforming it to other forms. This stage includes data from the cloud-based data warehouses and AWS portfolios as well, and also from Redshift or Aurora as well. Next, we move on to the compute layer in the stack. So unlike traditional applications, the ML applications need general purpose compute layer for heavy data processing, as we have like millions and millions of data in the data sets which we choose. So there are different resources available for the same, like AWS Batch or Kubernetes as well. Next, we move on to the orchestration layer. We shouldn't be confused about the automation and the orchestration that's happening in the ML applications. Why? Because automation is setting up of one task to run on its own, while orchestration is running many tasks as a process. So this orchestration also helps in coordination of entire organization's DevOps practices and automation tools. Now we'll talk about versioning. As ML applications undergo many upgrades as dynamic operations, we have to have a strong versioning layer in order to keep track of the models we have built, so that if we go wrong at one stage, we can certainly come back to the previous stage and continue our operation. Coming to the software development layers, we know generally that the software layers will have to be more abstract in order to make people productive, and also we need and hence we need an advanced level of software development layer. Not only because of that, but because also as we're using the machine learning programs, we need to directly run the data on top of compute and orchestration layers. Software architecture in machine learning applications should be mainly in terms of APIs and libraries. so that they can allow the scientists to focus mainly on the data and not on the machines alone. And hence they are built by data scientists and not software engineers, because mainly because the ML applications are quite complicated and they are very much different from that of traditional software development. We studied about 5 layers before this, and none of the layers helps us in modeling and optimization. That is why data science layers comes into action, and then they help us to go from the raw data to the features right away. And the model operations include assigning weights and biases to the data which we have taken so that we can perform operations on them. So now, after assigning perfect weights to the inputs which we have taken, what we do is we convert this data into features, which is most important part of an ML application. This stage involves feature encoders and feature stores as well in order to for our data to be converted to data to features. After all the data have been converted into features, next we develop the model. We develop the models usually in order to provide the functions like predictions so that our ML applications predict something as a function. And to do this, we use libraries like scikit-learn and PyTorch. And obviously, after the model is developed, we have to test it for its run, how exactly it is running and how exactly it's giving the outputs. So, as in this traditional software engineering, we use unit test, we use A/B testing here, and one catch is that all the layers of the stack must be able to run several versions of the applications at the same time in order to be tested. And as I've explained till now, there are much difference between DevOps and MLOps, and the main player here is the data. Data makes them different. Data works differently in DevOps, and data works differently in MLOps as well. Thank you.